Hey there, and welcome. Today we're going to map out the entire data journey, all the way from a simple business question to a really powerful, actionable insight. We'll connect the dots between dozens of concepts, from SQL to machine learning, and turn it all into one single story. Okay, let's dive in.
Think about it. Every single time Netflix recommends a show to you, that recommendation is the final stop on a long, complex journey through data. So let's walk that same path together, step by step, and see exactly how raw, kind of messy numbers get turned into major business decisions.
Every great data journey, it doesn't start with data. Nope. It starts with a question. A really clear, specific business question. Before you write a single line of code, you have to know why you're even doing it. What are we trying to achieve here?
So to guide us on this journey, we need a compass. And in the world of data, that compass is the key performance indicator, or KPI. And listen, this isn't some vague, fuzzy goal. It's a hard, measurable value. Are we trying to increase our daily users? Are we trying to boost sales by 10%? A clear KPI tells you exactly what winning looks like. Okay, so how do we actually improve that KPI? Well, one of the most powerful tools we have is A/B testing. It's actually pretty simple. We take our current version, that's the control, and we test it against a brand new idea, the treatment. We show each version to different groups of users, measure the results, and let the data tell us which one is better. No guesswork needed.
All right, so we've got our question, and we know how we're going to measure success. Now we need the raw materials, the data itself. And that brings us to the second stage of our journey. We got to find, gather, and organize all this information that's tucked away in our digital archives.
See, these databases can be just unimaginably huge, holding millions, sometimes billions of records. You can't just scroll through it like a spreadsheet. You need a special language to ask very precise questions so you can get exactly the slice of data you need. And that language is SQL.
And check this out. This one line shows you just how powerful SQL is. This simple command is basically telling the database, hey, go look at the sales table, add up every single number in the amount column, and just give me the grand total. Boom. In one command, you've answered a huge business question. What's our total revenue? But here's the thing. Data is almost never in one neat little box. You might have your customer info in one table and all their orders in a totally separate one. So how do you connect the two? Well, that is the magic of a foreign key. It's the bridge that links related information together, letting us build a single, complete picture. Now, this is where SQL gets really slick. You see, both where and having are used for filtering, but it's all about when they do their job. Where filters individual rows before you do any math. Having, on the other hand, filters entire groups after you've already done a calculation, like a sum. It's a subtle difference, but it's absolutely crucial for getting the right answers. And to make sure all this data is actually trustworthy, databases have these 4 fundamental rules, known as the asset properties. You can think of it as a promise, a guarantee from the database that your data won't get messed up or corrupted, even if thousands of things are happening all at once.
All right, we've got our question and we've gathered our clean data. Now for the really fun part, the analysis. This is where we go beyond just looking at numbers. We start digging for the hidden patterns and the secret relationships that lead to those aha moments, the real insights.
So much of modern analysis is powered by machine learning, and honestly, it often boils down to 2 main jobs. There's regression, which is what you use when you want to predict a number, like forecasting next month's sales, and then there's classification, which is for predicting a category, like figuring out if an email is spam or not. But there is a massive pitfall here. A model can actually get too smart for its own good. It's called overfitting. It's what happens when the model doesn't just learn the real patterns, it literally memorizes the random noise in the data it was trained on. So yeah, it looks like a genius on the old data, but it totally fails when it sees anything new, which makes it pretty much useless. So, to fight this, analysts have a whole toolkit of defensive moves. Techniques like regularization, cross-validation, and dropout. They're all designed to stop the model from just memorizing. They force it to learn the general underlying patterns that will actually help it make good predictions in the future.
So how do we know if our classification model is any good? Well, we use metrics like precision and recall. Precision asks, of all the times we predicted yes, how often were we right? And recall asks, of all the things that were actually yes, how many did we manage to find? The tricky part is, these two are often fighting each other, and you have to decide which one is more important for your specific problem. And I have to give you a huge warning here. High accuracy can be a trap. Seriously. Imagine you're trying to detect a rare disease that only 1% of people have. A model that just says no every single time will be 99% accurate, but it's completely useless. This is exactly why we need metrics like precision and recall. Context is everything.
As we're hunting for all these patterns, we have to remember the absolute golden rule of data analysis. Correlation does not equal causation. Just because two things happen to move together doesn't mean one causes the other. I mean, ice cream sales and shark attacks are highly correlated, right? But one doesn't cause the other. They're both driven by a third thing, hot weather.
You know, sometimes our data has these weirdos, outliers, extreme values that can totally throw off the whole analysis. To deal with them, we have a few standard strategies, like capping the extreme values, just removing them, or using special models that are built to be less sensitive to them.
Okay, we are on the home stretch. We've asked our question, we've wrangled our data, and we've found a real insight. But the journey isn't over. The last and maybe the most important step is to communicate what you found so that other people can understand it and, this is the key, act on it.
And to do that, analysts pick the right tool for the job. You know, Excel is amazing for quick summaries and little calculations. Python is the absolute workhorse for any kind of heavy-duty data manipulation. And then tools like Tableau are fantastic for creating interactive visuals that let people explore the data for themselves.
And what's really cool is that in the last few years, building these powerful, interactive dashboards directly in Python has gotten way easier. Frameworks like Dash and Streamlit let analysts turn their complicated code into these simple, intuitive web apps that business leaders can actually use to get live insights.
And really, this is the bottom line. The most brilliant analysis in the world is completely worthless if it just stays locked away in a script or a spreadsheet. The whole point of this entire journey is to turn complexity into clarity, and ultimately, to turn data into decisions.
So there you have it, the whole data journey laid out in 4 clear stages. You always start with a business question. Then you wrangle the raw data. After that, you uncover the hidden patterns. And finally, you bring those insights to life through clear communication.
This 4-part structure is basically a map that can guide any data project you can think of, from a simple analysis to a really complex machine learning system. So the only question left is, where are you going to start your exploration? Thanks for joining us.